C# programming language. What is C#? Introduction to C#. C# is a simple, modern, object-oriented, and type-safe programming language. It will immediately be familiar to C and C++ programmers. C# combines the high productivity of rapid application development languages and the raw power of C++. Visual C#.NET is Microsoft's C# development tool. It includes an interactive development environment, visual designers for building Windows and web applications, a compiler, and a debugger. Visual C#.NET is part of a suite of products called Visual Studio.NET that also includes Visual Basic.NET, Visual C++.NET, and the JavaScript scripting language. All of these languages provide access to the Microsoft.NET framework, which includes a common execution engine and a rich class library. The .NET framework defines a common language specification CL's a sort of lingua franca that ensures seamless interoperability between CL's compliant languages and class libraries. For C# developers, this means that even though C# is a new language, it has complete access to the same rich class libraries that are used by seasoned tools such as Visual Basic.NET and Visual C++.NET. C# itself does not include a class library. History of C#. C# was created at Microsoft late in 1990s and was part of Microsoft's overall .NET strategy. C#'s chief architect, Anders D.S.D. urged C# directly related to C++ and Java. Why C#? More powerful than Java. Much cleaner than C++, minimal learning curve for everybody. C# family tree. The family tree of C# is shown here. The grandfather of C# derives its syntax, many of its keywords and its operators. C# built upon and improves the object model defined by C++. If you know C or C++, then you will feel at home with C#. The evaluation of C#. Language evaluation criteria. Readability. The ease with which programs can be read and understood. Writability. The ease with which a language can be used to create programs. Reliability. Conformance to specifications. Cost. The ultimate total cost. Evaluation criteria. 1. Readability. Overall simplicity. The manageable set of features and constructs. Minimal feature multiplicity. Minimal operator overloading. Orthogonality. A relatively small set of primitive constructs can be combined in a relatively small number of ways. Every possible combination is legal. Too much orthogonality can also cause problems. Data types and control statements. Adequate predefined data types. Syntax considerations. Identifier forms. Flexible composition. Special words and methods of forming compound statements. Form and meaning. Self-descriptive constructs. Meaningful keywords. Evaluation criteria. 2. Writability. Simplicity and orthogonality. Few constructs. A small number of primitives. A small set of rules for combining them. Support for abstraction. The ability to define and use complex structures or operations in ways that allow details to be ignored. Expressivity. The set of relatively convenient ways of specifying operations. Strength and number of operators and predefined functions. Evaluation criteria. 3. Reliability. Type Cherokee. Testing for type errors. Exception handling. Intercept runtime errors and take corrective measures, and then continue. As examples data, C++, Java, etc. Availability. Presence of 2 or more distinct referencing methods for the same memory location. Readability and writability. A language that does not support natural ways of expressing an algorithm will require the use of unnatural approaches, and hence reduced reliability. Evaluation criteria. 4. Cost. Training programmers to use the language. A function of simplicity and orthogonality. Writing programs. A function of closeness to particular applications. Compiling programs. First generation AV impediment. Executing programs. A function of language design. A concern in the design of early plurals. Language implementation system. Availability of free compilers, less expensive hardware. Reliability. Poor reliability leads to high costs. Maintaining programs. A function of readability. Other evaluation criteria. Portability. Generality. Well-definedness. Portability. The ease with which programs can be moved from one implementation to another, a function of degree of standardization. Generality. The applicability to a wide range of applications. Well-definedness. The completeness and precision of a language's official definition. Features that Java lacks. Cross-language interoperability. Full integration with the Windows platform. To answer these and other needs, Microsoft developed C#. C# compared to Java and C? What is the .NET framework? The .NET framework defines an environment that supports the development and execution of highly distributed component-based applications. As it related to C#, the .NET framework defines two very important entities: Common Language Runtime.cr versions of C#. Since its original 1.0 release number sign has been evolving at a rapid pace. Not long after C# 1.0, Microsoft released version 1.1. It contained many minor tweaks but added no major features. However, the situation was much different with the release of C# 2.0. C# 2.0 is a watershed event in the life cycle of C# because it added many new features such as generics, partial types, and anonymous methods that fundamentally expanded the scope, power, and range of the language. Version 2.0 firmly put C# at the forefront of computer language development. It's also demonstrated Microsoft's long-term commitment to the language. The next major release of C# was 3.0, and this is the version of C# described by here. Because of the many new features added by C# 2.0, one might have expected the development of C# to slow a bit, just to let programmers catch up, but this was not the case. With the release of C# 3.0, Microsoft once again put C# on the cutting edge of the language design. This time adding a set of innovative features that redefine the programming landscape. How C# relates to the .NET framework. Although C# is a computer language that can be studied on its own, it has a special relationship to its runtime environment, the .NET framework. The reason for this is twofold. First, C# was initially designed by Microsoft to create code for the .NET framework. Second, the libraries used by C# are the ones defined by the .NET framework. Do 7000 is theoretically possible to separate the C# language from the .NET environment. In practice, the two are closely linked. Because of this, it is important to have a general understanding of the .NET framework and why it is important to C#. What C# 3.0 has added to the language. Anonymous types, auto-implemented properties, extension methods, implicitly typed variable, lambda expression, language int eed query, object and collection initializes, partial methods. C#.NET Object Orientation. .NET supports object-oriented programming with single implementation on inheritance of classes and includes encapsulation, inheritance, polymorphism, abstraction, method overloading, and method overriding. Encapsulation, the group of related properties, methods, and other members are treated as a single unit or object. Inheritance, the ability to create new classes based on an existing class. Polymorphism, you can have multiple classes that can be used interchangeably, even though each class implements the same properties or methods in different ways. Abstraction, the ability to generalize an object as a data type that has a specific set of characteristics and is able to perform a set of actions. Method overloading, the ability to define several methods all with the same name. Method overriding, this allows a subclass to override a specific implementation of a method that is already provided by a superclass. Garbage collector and security in .NET. Garbage collector. Garbage collector GC is .NET's answer to memory management. Garbage collector manages the memory in managed code for you. The purpose of garbage collector is to clean up memory. However, there are some limitations to garbage collector, wherein you are responsible for recourse in unmanaged code. Garbage collection is not deterministic. In other words, you cannot guarantee when the garbage collector will be called. It will be called when the CLR decides that is needed. However, it is also possible to override this process and call that garbage collector in your code manually. Security. .NET excels in terms of complementing the mechanisms provided by Windows by offering code-based security. Code-based security is based on what the code actually does and on how much the code is trusted. .NET also offers a mechanism by which code indicates in advance what security permissions it will require to run. .NET runtime has been designed so that malicious code cannot infiltrate and execute on a remote machine. You need to understand the restrictions that the CLR places on your assemblies. Code-based security reduces the risks associated with running code of dubious origin, such as those that are downloaded from the internet.